So far, we have talked about the definition of displacement, distance, speed, and velocity, and we define the velocity as the ratio of change in position to change in time. Uh, Now we will define this velocity in a different term where we will use a linear graph where our y-axis is position and the x-axis is time. Uh, it, if you recall the algebra, uh, we can see that if you recall the uh, knowledge from algebra, we can say that the slope of any line, any curve is the ratio of rise and run. And if we plot a graph where our y-axis is x, so this is position, and x-axis is time. And uh, if you look at a section here, and if we uh, try to calculate the change in position from moving from x1 to x2 position, we can represent it as delta x is equals to final position minus initial position. Similarly, if we are looking at the run, here the initial time is t1 and the final time is t2, so the change in time delta t is equals to final time minus initial time. And if we want to calculate the slope of this straight line, we can get this by the ratio of rise, which is change in this position, over run, which is change in this position. So delta x over t. And from previous videos and previous lecture materials, we know that the ratio of change in position to change in time is defined as the velocity. So basically we can say that the slope of position versus time graph is velocity. So we can say that the slope of a position versus a time graph is the slope, is the velocity. And one more thing we need to note here is that if we have a straight line, like here, this is a straight line. If we take a slope here, if we take a slope here, or here, or here, at any point, the slope will be the same. Because it's a straight line, the slope at any point here will be the same. That means the slope is constant. Slope at any point is the same, which means that is constant velocity. So that basically means if the slope is same throughout the time we are observing the data, if the slope is same, that means the velocity is not changing and the motion is constant velocity. And with that, we need to understand what the steepness of this slope represents. So here we have a question which is asking which of this car is going fastest, A, B, or C, and which is traveling the slowest. So we have a graph where our y-axis is position, x-axis is time, and we have three different uh, for example car A, car B, and car C, and the position versus time is plotted in this graph, and we can see this is the position versus time for A, B, and C, and we can see the slope of this line is smaller than slope of this line, is smaller than slope of this line, and so on, right? So this is uh, if this is slope 1, slope 2, and slope 3, then slope 3 is sorry, slope 3 is larger than slope 2, and slope 2 is larger than slope 1. What this represents is uh, uh, what this represents is that a steeper slope means a greater change in position over the same amount of time. For example, here, if we are interested in this amount of change in time, delta x, and if you just draw that in this portion here, so this will give us the slope. And if you look at this y position, this is delta x, and similarly if you extend this here, and this is delta x. Similarly, if you do the same here, now if you look at this delta x for each case, if you see here, this is a small size, the length of this delta x is smaller than this one, and this delta x is even smaller than this one. And we know delta x over delta t is the velocity, and delta t is same for all these three cases. So if delta t is constant in these three cases, basically if we are increasing the numerator, that means we are increasing the overall slope. So that means the slope is lower here, low velocity, and velocity highest, and the slope of velocity of the car B is in between A and C. So this is how we can see that for the same change in time, if we have different stiffness, different slope of a curve, the change in position will be different, so resulting in different velocity, and higher the slope, the steeper the curve, higher the slope, that means higher the velocity. Now we can see that here uh, in this curve, in this animation, we can see all these three cars start at the same position, and this red curve is corresponding to red car, green curve is corresponding to green car, and blue car is corresponding to green curve. And we can see at the same time the blue car with the highest velocity has passed the highest distance from here to here. So delta x blue is higher than delta x green, and the lowest is delta x red. And we can see the time period is same for all these three car, and if the change in position is higher, that means the slope is higher. So this is highest slope, moving fastest. Lowest slope, moving slowest. So we can watch it again. The fastest car has the steepest position versus time graph, and slowest has the lowest slope. And now let's see this graph and what can we say about the speed of the car and what's going on based on this curve. Again, our y-axis is position, x-axis is time, and we can see as the time passes, which is time is changing from, if this is t1 and this is t2, even when the time is changing, we can see there is no change in x position. So change in position delta x is equals to x final minus x initial. Here x final and x initial are 0. That means slope is equals to delta x over delta t, which is 0. What this graph, straight line in a horizontal straight line shows us that the slope is 0, basically means it's a car move that's not moving. So velocity is equals to 0, or we can say the car is at rest. Even though the time passes, there is no change in x position, meaning the car is at rest. And now let's consider this graph where the initial position is x1 here and the final position of the car is x2, and the initial time is t1, initial time is t2. What is the car doing here? And if we look at here, what do we know? Slope is equals to change in position over change in time. And if you look at this graph, we know in y-axis, if you go from bottom to top, you are moving in positive direction. And this is positive. And in terms of time, if you are going from left to right, you are moving in positive direction, right? So the initial is at this point and the final is at this point, meaning your initial value is larger than your final value. And what is delta x? Delta x is x final minus x initial, and time is sorry, I can use the same notation as in the graph. Final minus initial over final minus initial. And if you see what is x2, x2 is smaller than x1, right? Because this is the positive direction and this right here is higher than this right here in terms of y coordinate. So your result will be negative And if the slope is negative, that means velocity is negative. If the slope is negative, then the slope of a curve is basically the velocity, so that means the velocity is also negative. What does that mean physically? Physically we can say the car is toward a negative direction, or if we are using the same coordinates, we can say the car is moving toward the left. And now we know how this linear line works, where if the curve was a straight line, the slope at any point will be the same, so the slope will not change, and we will have only one slope, means constant velocity. Now instead of straight line we have non-linear, not uh, straight line. Now we need to know how does this car's speed change at time t2 compared to t1. So the initially the car's speed versus the final car's speed, how does it change? What is the car doing, whether it's going positive direction or it's going negative direction. And we know the velocity is slope, and for a curve here, if you want to calculate the slope at this point, what we need to do is draw a tangent passing through this line. And if we want to calculate the slope at this point, what we will do is basically calculate the rise over run for this tangent line, delta x, delta t. Similarly, if we want to look at this point at t2, if we want to calculate the velocity at this point, again we will draw a tangent passing through this point. And now if we want to draw the slope, it's a straight line now because the tangent is a straight line. You can calculate slope at any point. And if you look at this case here, we can see the change in position. This is x1, this is x2. Change in position is x2 minus x1. This is positive because x2 is bigger than x1. And if you look at the slope of these two tangents, 1 and 2, we can see that this curve is steeper, meaning the velocity increases. So the velocity at t2 is higher compared to velocity at t1, and since x2 and x1, x2 is higher than x1, we can say the change in position is toward the positive direction. So basically we can answer this: how does this car's speed at t2 compared with this is higher, and what is this car doing? We can say moving toward positive direction. One more example again. We need to compare the velocity at t2 compared to t1, and let's see. First, draw a tangent line and draw a tangent line. So it's a tangent line shouldn't look like this. Tangent lines should just only touch at one point like this, and we can see the slope of this line is comparatively the first line. Slope at t1 is higher than slope at t2. We can see this is a higher slope compared to this, and in terms of position, if you look at here, it started at t1 time, so this should be x1, and at x2 this should be x2. Your final position is bigger than smaller initial position, so delta x is equals to x2 minus x1, which is positive. And we can say, now we can answer the question. We can see how does this car's speed at t2 compare with its speed at t1. Now we just drew the slope. So the slope at t2 is smaller. That means speed at t2 is lower than t1, because the slope at t1 is higher than slope at t2. And what is this car doing? It's moving, and again this is the final position and this is the lower position, and final position is toward the positive direction, so moving toward positive direction. Or if we are still using the same sign convention, we can say toward right. And one more case, instead of a concave line we have a convex line, and if you look at here, t1 position is this, so the position time t1 is this, and the position with respect to time t1 is the initial position x1, and the position corresponding to time t2 is the final position x2. And we want to know the velocity, so we will draw a tangent line. If we draw a tangent line here and a tangent line here, we can see that the slope of this is lower and the slope of this line is higher, meaning the velocity at this point is higher than the velocity at t1. And so we can say, how does this car's speed at t2 compare with car's speed at t1? So we can say this is higher. And for the second question, what is this car doing? So basically what it's doing is, what is it doing? The initial position, final position minus initial position, and here we can see x2 is smaller and x1 is larger. So if this number is smaller and this number is larger, the resultant answer of change in position will be negative. So the velocity at the slope is negative. That means the car is moving toward left or negative direction. And one more case, how does this car's speed at t2 compare to its initial speed at t1? So the corresponding position at time t1 is initial position x1, corresponding position at T2 is final position x2. Then again, the final position is smaller than initial position, so our answer for the second part is 2 or negative. And for the first part, let's draw a slope here, and let's draw a slope here. We can see slope is higher, and we can see slope is lower. So the velocity at T2 is velocity of the car at T2 is smaller or lower than velocity at T1, and the car is moving in negative direction. And here are some questions. I will also upload the files so you can go through these questions and try to answer these questions by yourself to check the knowledge from this section.